in order to be able to manipulate or observe or remove a particular gene from the DNA of an organism, it needs to be located first. So we've got big long strands of DNA and these massive base sequences. So if we want to find a very particular gene, we need to do something in order to work out where it is. So that's where gene probes come into play. Now, if we have a sequence of DNA, like so, just come up with something random. And then I'll just draw in a bit of a backbone. So this is going to be a single strand of DNA. So a double helix has been opened up, for example. We've got these exposed bases. What we might want to do is we might want to specifically find on a long strand of DNA this GTACG sequence. So this might be a particular gene, particular segment of interest for us, and we want to work out where in the genome that is, whereabouts on a chromosome individual that sequence of DNA is. So in order to do that, what we can do is use a gene probe. So gene probes are single-stranded segments of either DNA or mRNA, and what we do with them is we create them in a lab so that they're complementary to a gene that we want to locate or a segment of DNA that we want to locate, and we mark them. And then when we introduce the gene probe, it will go in bind in a complementary manner to a segment of DNA of interest, and we can then see where it is. So if we wanted to locate this particular gene, what we would do is we would make a gene probe that has a sequence CA. So this is if we're talking about a DNA gene probe, so we're going to have CAT. It would obviously be CAU if we had an mRNA gene probe. So we're working with DNA gene probe. So we've got CATGC. So we would make this gene probe with this particular sequence because it's complementary to the sequence of interest. Drawing our backbone here. But there's one little difference, or one little extra thing that we need to do. What we would do to this gene is we give it a radioactive or fluorescent mark. So we're going to hang on, I'm going to work out. Let me see if I can find how to spell this. Fluorescent, I think. So it's going to be either a fluorescently marked or radioactively marked. Fluorescently marked or radioactively marked segment of DNA. So the reason for this is because when it goes and binds to a gene of interest, like so, the fact that it has this fluorescent or radioactive marking means that we are going to be able to see it, and we're going to know where specifically it is. So we know of a particular gene we want to find, we know of its sequence, we then make a gene probe that has a complementary sequence out of DNA or mRNA, we fluorescently or radioactively mark it, we then introduce it to that gene, then it will bind in a complementary manner to the gene, show us where it is because of its fluorescent or radioactively fluorescent or radioactive marking. So then we now know where that gene is, and whatever we need to do with that gene, we can then start going about removing it or analysing it or something like that.